Okay, in this video we're going to introduce the magnetic force and magnetic fields. So just recall that an electric charge creates an electric field, and the higher the charge and the closer you are to the charge, the stronger the electric field. So the electric field is K Q over R squared. And if you put an electric charge in an electric field, then there's a force on that electric charge. And the stronger the electric field and the higher the charge, the stronger the force. So that would be, right, the electric force is Q, your charge, times the strength of the electric field that you're in. So the higher your charge, the stronger the force. The higher the electric field, the stronger the force. But that electric field, right, is mediated by the charge of the other charge and your distance from that charge. So down here we have two positive charges, they're next to each other, and they both feel the electric force pushing them away from each other because like charges repel. And that the stronger the charges that we put there, the stronger the force, and the closer together, the stronger the force. So there are a lot of parallels with the magnetic field and the magnetic force. So the magnetic field is B with an arrow, and magnetic field is created by moving electric charges. So if you're a stationary electric charge, you do not create a magnetic field. Once you start moving, now you're producing a magnetic field. So similar to electric field, the higher the charge, the stronger the magnetic field. So if I put a 1 coulomb charge versus a 2 coulomb charge, there would be a higher magnetic field from the higher charge. And because magnetic field only deals with moving charges, we can also say that the higher the velocity, the stronger the magnetic field. So if magnetic fields are about moving charges, well, the more you're moving, the more magnetic field you produce. And also like electric charges, the closer you are to the charge, the stronger the magnetic field. And again, those are both inverse square laws. And you can see that the main difference here is that now for magnetic fields, we care about the velocity of the charge. And if you have zero velocity, you have zero magnetic field. If you look at the pictures and just compare what the fields look like, electric fields are lines, and they point in the direction that a positive charge would go. In magnetic fields, so what I've drawn is this line here with I. Remember, I is current, so we have charge moving up, and that creates a magnetic field that is perpendicular to that movement. So I try to draw these circles in perspective. So it creates concentric circles, which are not lines, right? These are loops now that always connect with each other. And the further away you get from the current, the weaker it is. So the magnetic field out here is pretty weak, but the magnetic field really close to the wire is pretty strong. And just like in electric fields, there's a direction associated with the magnetic field. And we'll talk about how to find that direction in the next video. But I've drawn in arrows to show you the direction. Here, I can draw you another picture. So say we have a current that's going into the board right now, or into this. This is the symbol for that, and we'll go over that in the next video too. This is just to see a different perspective. So say the current is going into the board. Oh man, that was bad. Then the magnetic field that you would see would look like this. And so just imagine that these are circles, and they're pretty. And then you'd have a magnetic field that looks like this. And again, I'm just trying to show you that they're always circles, and they're perpendicular to the direction of the velocity of the charge. Okay, so then a moving electric charge in a magnetic field is acted on by the magnetic force. Just like a charge in the electric field is acted on by the electric force, a moving charge in the magnetic field is acted on by a magnetic force. And so the stronger the magnetic field, the stronger the force, just like for electric force. The higher the charge, so the higher your charge, the higher the magnetic force, and the higher your velocity, the higher the magnetic force. And you can see the similarities again with the electric force. And again, I'll show you this in the next video, but if I have two currents, so two moving charges going this way, they will attract. I'm drawing two wires here.